Welcome back to 3D Decode. Today, we're talking about one of the most important and interview-heavy standards in rotating equipment, API 682, mechanical seal systems. If you're preparing for refinery, petrochemical, or oil and gas interviews, this topic is a must-know. Let's decode it step by step 1. What is a mechanical seal? A mechanical seal is a device that prevents leakage between the rotating shaft and the stationary casing of pumps and compressors. It is more reliable than packing or lip seals, essential for toxic, flammable, or high-pressure fluids, widely used in refineries and gas plants. In short, if the seal fails, the machine fails. 2 basic seal components. Let's quickly look at the major parts of a seal. Rotating face, attached to the shaft. Stationary face, fixed in the gland housing. Secondary seals, O-rings, gaskets, spring or metal bellows, provide closing force. Seal support system supplies buffer, barrier or flush fluid to keep seals healthy. 3 seal arrangements API 682. Seals can be arranged in different ways depending on process needs. Single seal, 1 sealing interface, used for clean, non-hazardous fluids. Dual seals, tandem, in series. For high containment, back-to-back. Opposed, for high pressure. Face-to-face, less common for seal support systems, seal plans. This is the heart of API 682, the standardized piping plans. Plan 11, internal recirculation. Flush taken from pump discharge, through an orifice, to seal chamber. Purpose, cool and clean. The seal faces. Plan 32. External flush. Clean external fluid injected into seal chamber. Keeps dirty or polymerizing fluids away from seal faces. Plan 52. Buffer fluid, unpressurized. For dual unpressurized seals, buffer fluid, like water, glycol, circulates between seals, monitored for leakage. Plan 53. A/B/C. Barrier fluid, pressurized. For dual pressurized seals, barrier fluid kept at higher pressure than process. Prevents process leakage escaping. Instead, barrier fluid enters the process. Variants differ by pressure control. Bladder accumulator, 53A. Piston, 53B. Thermosiphon, 53 degrees Celsius. Plan 62. Quench. Low-pressure steam, nitrogen, or water applied on atmospheric side. Prevents coking, icing, or crystallization. 5. Why seal plans are important. Ensure long seal life. Prevent leakage of hazardous fluids. Reduce maintenance downtime. API standardization equals global safety and reliability. Mini quiz. Drop your answers in the comments. 1. Which API standard governs mechanical seals and support systems? 2. What is the main purpose of a mechanical seal? 3. In API Plan 53, is the barrier fluid pressure higher or lower than process pressure? 4. Which plan injects clean external flush fluid to the seal chamber? The practical task. Sketch 2 common seal plans from memory. Plan 11, internal flush. Plan 53A, barrier fluid with bladder accumulator. This will help you visualize piping connections and will really impress interviewers. Interview, Q&A, Day 5. Q. Explain the difference between Plan 52 and Plan 53. A. Plan 52 uses buffer fluid at lower pressure. Detects leakage. Plan 53 uses barrier fluid at higher pressure. Prevents leakage. Q. Why are dual seals used in refineries? A. To safely handle hazardous, toxic, or high-pressure fluids where single seal leakage is unacceptable. Q. What happens if seals run dry? A. Heat generation, face damage, and catastrophic failure. Q. Why is Plan 11 not suitable for dirty fluids? A. Because solids from discharge would enter seal chamber and damage the faces. Q. What is the role of a seal gas system in compressors? A. to supply clean, pressurized gas to dry gas seals, as per API 692, ensuring reliability. Outro. That's all for today's deep dive into API 682 mechanical seal systems. If you found this useful, don't forget to like, subscribe, and share your quiz answers in the comments. This is 3D Decode, simplifying complex engineering concepts. See you in the next one.